I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we will discuss about smoothing spatial filters. So, in this smoothing spatial filters, there will be two classifications. One is linear filter and another one is non-linear filter. In this session, we will discuss smoothing spatial filters in linear filters classification. So the internal topics what we are going to cover are, so in this smoothing spatial filters, there will be two classifications. One is linear filters and another one is non-linear filters. So under linear filters, we are going to cover average filter, which is also called as mean filter. And next we will see some example problems on averaging filter. That means if the image is given, how to apply averaging filter on that image in order to make it smoother. So spatial filtering, in the spatial filtering, we have two classification. One is smoothing spatial filter and another one is sharpening spatial filter. So smoothing spatial filter means using this filter, we are going to blur the image in order to reduce the noise. So this sharpening spatial filters will be covered in the upcoming sessions. In this session, we will cover this smoothing of spatial filter. So in this smoothing spatial filter, again we have two categories. One is linear filtering and another one is non-linear filtering. Now, under linear filtering, we are going to see average filter, which is also called as mean filter. That means here, if you are going to apply filter on the image, we are going to consider the neighborhood pixels of that image and we are going to calculate the average values of that pixels in this linear filtering. That's why it is called average filter or mean filter. Whereas in non-linear filtering, we have different types of filters like median filter, minimum filter and maximum filter. So here in the median filter, in the given image, wherever the mask we are going to apply, we have to consider all the neighborhood pixels along with the center pixel. We have to write all the pixels in the ascending order. After writing that in the ascending order, whatever the value, pixel value that is present in the middle, that value will be considered as the modified pixel value in case of this median filter. In case of minimum filter, same thing we have to do. That means in the given image, first we have to know on what pixels we are going to apply mask. Considering all the pixels, we have to write the pixels in the ascending order. After writing that in the ascending order, whatever the pixel is there in the minimum place, that is in the first place, that value, pixel value will be considered as the modified pixel value. Similarly, maximum filter, considering all the neighborhood pixels of the center pixel, arranging them in the ascending order, then we have to see which pixel is the maximum pixel and considering that maximum pixel value, we have to consider it as the modified pixel value. So these are the three filters that comes under non-linear filtering. We will cover this in the upcoming sessions. In this session, we are going to cover linear filtering and we are going to learn about this average filter, which is also called as mean filter. So coming to some basic concepts under this smoothing spatial filters. So what is the purpose of smoothing spatial filters means? The smoothing spatial filters are used for blurring the image or for reducing the noise that is present in the image. That means here, if you come for the pre-processing steps, as soon as the image is acquired, that image will be considered as the raw image. So blurring is used in this pre-processing steps. So the main function of blurring in the pre-processing steps are in order to remove small details present in an image. So if you remove small details present in an image, the main intention is to extract the object that is under interest. And another reason is to bridge the small gaps that is present between curves and lines in the image. This blurring concept can be used. And so using this blurring, noise can be reduced, and this can also be done by using some basic filters like low pass filter. And this noise reduction by using this blurring can be done by using two types. One is linear filtering and other one is non-linear filtering. So in this session, we are going to discuss about this linear filtering. And in the upcoming sessions, we will discuss about this non-linear filtering. So in this linear filtering, what we are going to do means, we are going to know what are all the pixels that are present under the mask. Considering that pixels, we are going to calculate average value of the neighborhood pixels, and we are going to find the modified pixel value. That's why this linear filtering is also called average filter, or it can also be called as mean filter. Now, so here it is clearly given. Average filter is also called as mean filter. Why? Because the output value what we are going to calculate, we are going to calculate based on the average value of the neighborhood pixels. That is why it is called averaging filter or mean filter. Linear filtering is also called as averaging filter or mean filter. So the response of the average filter, that is how the output of the average filter will be, means the output will be the smoothened image. So the smoothened image is used to reduce the sharp transitions in the gray level. Smoothing is used to reduce the noise. So if we consider here, this is an image and its size is of 3 by 3. So if we consider here 3 by 3, the number of pixels that are available in this image are Z1, Z2, Z3, Z4, Z5, Z6, Z7, Z8 and Z9. So as it is 3 by 3 image, that is it consists of 3 rows and 3 columns. The total number of pixels that are available in this image are 9. Now, so these are the pixel values of the image. Now we have to consider the mask that we have to place on this image in order to find the new output values, that is smoothened image. So the figure here shows 3 by 3 averaging filter. So it is considered as a mask here. So if we see, this is standard average filter and this is weighted average filter. So what is the difference between these two means? In this average filter, we can see here all the filter coefficients. Here all the filter coefficients will be uniform, that is 1. Whereas here if you come to this weighted average filter, each coefficient will be having its own weights. So here all the weights are 1. That's why it is called standard average filter. And here if you consider the weights of all the coefficients 1, 2, 1, 2, 4, 2, 1, 2, 1, each one is having its own weight. Now, coming to this standard average filter, here all are 1s and here it is, we are going to multiply with 1 by 9. So why here it is multiplied with 1 by 9 means, so the given mask size, filter size is of 3 by 3. So totally it is having 9 coefficients and each value is 1. So if we consider how many number of ones are available here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally number of pixels available here are 9. That's why here we are writing it as 1 by 9, multiplying this mask or filter with 1 by 9. So if we consider here weighted average filter, so here if we consider it is 1 by 16. Previously it is 1 by 9. We have discussed just now why we have written 1 by 9. Similarly here it is 1 by 16. So what is here 16 represents means, if we add the coefficient values of all these here that are available in the filter, so 1 plus 2 plus 1 plus 2 plus 4 plus 2 plus 1 plus 2 plus 1. So total will be equal to 16. That is why here 1 by 16 is written. So how to calculate the total output pixel value means, R is equal to 1 by 9. So here how we got 1 by 9 means from here. So this is 1 by 9. Sigma I is equal to 1 to 9 Wi into Zi. So here Wi represents the weights. So in this standard average filter, weight is equal to 1, and here Zi represents the pixel values that are present in the image. So Wi into Zi, weight that is present in the filter, multiplied with each pixel value that is present in the image. So you can consider this as W1, W2, W3, W4, W5, W6, 7, 8, 9. Similarly, here also W1 to W9, which represents weight. So here I values we have represented, it is ranging from 1 to 9. So here why it is 1 to 9 means, the number of pixels or coefficients that are available in the filter are 9. That's why here 1 to 9. Similarly, coming to this weighted average filter, how to calculate the total or the new pixel value for the image means, R is equal to 1 by 16. So here how we got 1 by 16 means, from here we have written 1 by 16, average value of the neighborhood. And Wi into Zi means, Wi represents weight. If we consider here weighted average filter, each coefficient is having its own weight, different weights. So Wi represents weights here. So I will be ranging from W1, W2, W3, W4, W5, W6, 7, 8, 9. So it is from 1 to 9. I value is ranging from 1 to 9. And similarly, the number of pixels that are available in the image, as the image size is of 3 by 3, it will be 9. So here the range will be 1 to 9 Wi into Zi. So this is how we have to find the output pixel value. If we consider standard average filter, we have to follow this formula. If you follow this weighted average filter, we have to consider this formula. Now, so here, if we consider any image and if you are going to apply any filter on that image, the filter size may be different. Based on the size of the filter, the quality of the image will be available. So if we consider, this is the original image. On this original image, we can apply filter. So as we have seen in the previous slide, linear filter. If you are going to apply linear filter on this original image, you can also call it as a mask. If you are going to apply mask on the original image, the mask size may be different. The mask size may be 3, 5, 9, 15, 35. How we are going to decide the mask size means we can have any size of the mask, but that mask size should be odd in size, like 3, 5, 7, like that. We have to eliminate the mask size of 1. So if the mask size is 3, if you are going to apply the mask which size is of 3 on this original image, the smoothened image will be like this. Similarly, if you are going to apply the filter, that is mask, where its size is of 5 on this original image, the output image will be, the smoothened output image will be like this. If we apply the mask which is of 9 in size on this original image, the smoothened output will be like this. Similarly, the mask size is 50. If we apply this mask on this original image, the output smoothened image will be looking like this. If the mask size is 35, if you are going to apply this mask on this original image, the smoothened output image looks like this. So from all these figures, what we can observe, as the size of the mask increases, see here, as the mask size increases, we can observe there is blurring in the image. That means blurring in the image also increases. So if the blurring in the image increases, it means the quality of the image is reduced. So this is the effect if the mask size increases, and if you apply that mask or filter on the original image, the output images will be looking like this. So as the size of the mask increases, the quality of the image will get reduced. Now, so based on this concept, let us solve some simple examples. So use average filter to smooth the sub image as shown. So here this is the image they have given, and here this is the filter they have given. So here the image is 1, 2, 3, 4. It consists of 4 rows and 5 columns. And here this is the mask. Its size is of 3 by 3. By seeing this mask, we can understand that it is standard average filter. That means the given mask is standard average filter mask. So we can also modify this and we can write it as commonly 1 by 9 outside and making all these weights as 1. Now, so we have to apply this mask on this input image in order to get the smoothed output. So whenever we are applying mask on the image, if we apply mask on the image, whatever the center pixel is available in the image, that only can be modified. So modification is dependent on the neighborhood pixels as we are dealing with average filter. Now, so here if you put this mask on this image, so you can put the mask in the first case as the mask is of 3 by 3. We can put like this in the first case. So this 15 becomes the center pixel. We have to find the output value of this 15, modified value of this 15. In the next case, by shifting this mask, it will be present like this. The mask in the second case will be present like this. So if this is considered as the mask, then this 6 becomes the center pixel which need to be modified. Similarly, in the next case, we have to shift that mask. So if we shift that mask for the third time, then the 3 by 3 mask will be available on this pixel. And from here, this 14 will be the center pixel which we need to find. And in another case, by shifting the mask, if the mask is shifted like this 7 becomes the center pixel which we need to find. Again, if we shift the mask, then the mask will be coming here, and this 5 becomes the center pixel which need to be modified. And at the last time, if you shift this mask, this 9 will become the center pixel which need to be modified. Now, if we are going to apply this filter on this given image, this 5, 15, 6, 14, 7, 5 and 9, all these are the center pixels that need to be modified. Now, we have to find the new value of 15, new value of 6, new value of 14, new value of 7, similarly modified value of 5 and modified value of 9. So, the first pixel here is 15. So, in order to make this as the center pixel, here you can see this yellow color which is called the shaded region. That means where the mask we are going to put. So, if you put the mask like this 15 is becoming the center pixel. Okay. So, we are going to find the new value of this 15. So, if you calculate, so applying this mask, we can write and calculate the new value of R, that is new value of 15. So, how we can find? Wi into Zi. So, Wi represents weight of the filter and Zi represents pixel value of the image. So, we can write 1 by 9 into 6 plus next 1 by 9 into 8 plus next 1 by 9 into 9 plus and next one is 1 by 9 into 7 plus and next 1 by 9 into 15 plus 1 by 9 into 6 plus 1 by 9 into 3 plus 1 by 9 into 7 plus 1 by 9 into 5. So, instead of writing every time this 1 by 9, as the values here are having the same weights, we can take 1 by 9 common and we can directly write this as 1 by 9 into adding all these neighborhood pixels like 6 plus 8 plus 9 plus 7 plus 15 plus 6 plus 3 plus 7 plus 5. So, if you simplify this value, we are going to get the new value of 15. So, if we simplify, we will get 7.33. So, here 15 will be available, which you need to be replace this as 7.33. Similarly, we have to calculate for 6, 14. Okay. So, in order to calculate for 6, we have to shift this mask so that 6 will become the center pixel. So, we have shifted the mask in order to find the new value of 6. So, this 6 became the center pixel value. Now, finding the new pixel value of 6, we can write this as 1 by 9 into. So, as we have seen, instead of writing every time Wi as it is standard, we can write 1 by 9 common multiplied with 1. So, the values of all the neighborhood pixels, that is 8 plus 9 plus 10 and next 15 plus 6 plus 14 plus 7 plus 5 plus 9. So, if we simplify this, we are going to get the new value of 6. Its value is equal to 9.22. So, instead of this 6, we have to insert the new value, that is 9.22. Similarly, in order to find the new value of the center pixel 14, we have to shift this mask. So, if we shift this mask, this 14 becomes the center pixel. Now, finding the new value by using the formula, we can write 1 by 9 into, the values are added 9 plus 10 plus 12 plus 6 plus 14 plus 13 plus 5 plus 9 plus 3. So, if we simplify, we are going to get the new value of 14, So here the new value of 14 will be 9. So instead of this 14 in the output smoothened image, we are going to replace the value with 9. So similarly, up to now we have calculated the new values of this 15, 6 and 14. Next we have to find the new values of this 7, 5 and 9. So in order to make this 7 as the center pixel, we have to shift the mask such that this 7 will become the center pixel. So this is how. This 7 will become the center pixel by applying the convolution formula. So as the mask is having the weights, same weights, we can write it as 1 by 9 into, so the summation of all the neighborhood pixels. So if you make this 7 as the center pixel, the neighborhood pixel values are here 7 plus 15 plus 6 plus 3 plus 7 plus 5 plus 14 plus 16 plus 10. So if you simplify this, we are going to get the new pixel value of 7. So the new pixel value of 7 will be 9.22. That means instead of this 7, we are going to replace this 7 with 9.22. So this is the modified output pixel value of 7 after applying the average filter. Now, next we have to find the pixel value of 5, new pixel value of 5. So we have to make this 5 as the center pixel. So we have to shift the mask such that this 5 becomes the center pixel so that we can find the new value of 5. So in order to find the new value of 5, R is equal to 1 by 9. So here every time why we are writing 1 by 9 means as we are having same weights for the filter, if we write 1 by 9 common, all the weights will be equal to 1 instead of multiplying every time with 1 by 9. So this is 1 by 9 plus into 15 plus 6 plus 14 plus 7 plus 5 plus 9 plus 16 plus 10 plus 7. So if you simplify this, we are going to get the new value for this 5, that is 9.88. That means instead of this 5, we are going to replace this 5 with the new value, that is 9.88 after applying average filter. And the last pixel value what we need to find is 9. So in order to find, we have to shift the mask such that 9 becomes the center pixel value. So it looks like this. So 9 has become the center pixel value. Now if you perform the convolution operation between this mask and pixel values of the image shaded region, we will get 1 by 9 into here 6 plus 14 plus 13 plus 5 plus 9 plus 3 plus 10 plus 7 plus 8. So the result what we are getting here is, so for the pixel value 9, we are going to get 8.33. So this is the new pixel value which we need to replace in place of this 9. So this is how we have to find the new pixel values or the output pixel values after applying this average filter. So here this is the output image finally, which is called the smoothened image. After finding the new values of all the required pixels, so we have instead of 15, for 15 we have calculated, we got 7.33. For 6, we got 9.22, and for 14, we got 9, and for 7, we got 9.22, and for 5, we got 9.88, and for finally 9, we got 8.33. So this is how we have to find the output image by applying average filter on the given image. So let us solve another example related to this averaging filters. So compute the value of marked pixels if it is smoothed by a 3x3 average filter. So here this is the image they have given, and here they have given find only for the marked pixels. Here the pixels are marked 3, 2 and 1. These are the pixels that are marked, and for that pixels only we have to apply average filter and we have to find the new values in the output image. So here these are the values we have to find 3, 2 and 1. Instead of 3, 2 and 1, what are the output pixel values we are going to get after applying this average filter? So they did not give any type of filter that we need to use, but they have simply specified here 3x3 average filter. So by default we will consider the standard average filter where all its weights will be 1, which is multiplied with 1/9. So that is why here we have taken the standard average filter mask, what we have seen in the previous problem. So this is the standard average mask we have taken, and we are going to apply that on the given input image in order to find these marked pixel values. So the marked pixel value here, it is 3. So in order to find the new pixel value of 3, we have to place this mask on the image such that the 3 becomes the center pixel. So if you place the mask here, then only this 3 will become the center pixel. As usual, same as the previous problem, we have to find the new value in the output image for 3. So here same as all the weights are 1/9. If you take 1/9 common, the weights will become 1. If it is applied to all the neighborhood pixels of the center pixel, then the new pixel value can be calculated. So 1/9 into 5 plus 6 plus 7 plus 4, 3, 2, 4 plus 3 plus 2 plus 8 plus 7 plus 6. So the new pixel value of this 3 can be calculated. So if we simplify this, we will get 5.33. That means instead of 3, we have to keep in the output image as 5.33. Similarly, to find the new pixel value of the marked pixel 2, we have to shift this mask average filter such that 2 becomes the center pixel. So if we shift the mask, it will look like this, and this 2 will become the center pixel. Now we need to find the new value of this 2. So R is equal to 1/9, as we are using here the standard average filter where all its weights are 1/9, same, equal. So 1/9 into 6 plus 7 plus 8 plus 3, 2, 1, 3 plus 2 plus 1 plus the last row 7 plus 6 plus 5. So if we simplify this, we are going to get the new pixel value for this 2. So we will get the value as 5. That means here instead of 2 in the output image, we have to place the value 5. And next value what we have, next pixel value what we have to find is for 1. So here in order to find the new pixel value for 1, we have to shift this mask such that this 1 becomes the center pixel. So if you shift this mask like this, then this 1 becomes the center pixel. Now we need to find the new value of this 1. So considering the neighborhood pixels, multiplying that with the weights of the mask, we will get 1/9 into 7 plus 8 plus 4 plus 2 plus 1 plus 2 plus 6 plus 5 plus 3. So if we simplify, we are going to get the new value of 1. Its value is equal to 4.22. That means instead of 1 in the output image, we have to place the new value which is equal to 4.22. So in this problem, we have calculated all the output pixel values for the marked pixel in the image, that is 3, 2 and 1. So for 3, we got 5.33, and for 2, we got 5, and for 1, we got 4.22. So in the output image, only these pixels need to be modified, whereas the remaining pixels that are present in the image will remain same. So here, this is the input mask, what we have considered as the average filter, standard average filter, and this is the input image what they have given. So this is the input data. After applying this mask, if you find the new pixel values of all these marked pixel values in the image, then the output what we are going to get is the smoothened image. So instead of this 3 in the output image, we have marked as 5.33. Instead of 2, as we have calculated, we got 5. So instead of 1, pixel value 1, we got 4.22. So we have to modify only these pixel values, marked values. Whereas here the remaining values 0, 1, 2 and all these remaining values, whatever are available, other than that, all these values remains same as the input image pixel values. So this is how we have to apply average linear filters on the input image in order to get the smoothened output image.
Like, share and subscribe. Hit the bell icon for more updates.